Alright, so tonight's topic is going to be an introduction to integrated circuits, which sounds complicated if you haven't done any electronics before, but it's very important because I want to talk about a lot of these things on this channel. And also particularly because if you're one of these kids who did this electronics day thing recently with me, I gave you a whole bunch of parts and I promised you some things, and we're going to delve into those, and we need to understand what an integrated circuit is. So they come in many shapes and forms, but they look kind of like this. Well, this is the traditional sort of integrated circuit, but they come in a much wider variety of shapes nowadays. I don't unfortunately have, I had some different ones before, but they've disappeared. If you look on any electronics device, you will see many of them. Give me a second, actually. Here we go, we've got this thing here. So this thing is quite cool because it has several different styles of integrated circuits on it. So that's what an IC is an integrated circuit. And that just means that there's lots of little bigger things. So let's just say we have like our resistors and other bits and pieces we haven't talked about yet. Well, it turns out you can shrink them down and stick them inside one of these little things, or inside here. And they basically sort of print them, well, they don't print them, I don't know exactly what the correct term is, but they use lots of clever stuff to put the circuit into a very small space inside these things here. And the cool thing is, of course, is that every year they can fit more and more and bits and pieces into a smaller and smaller space. But the sad thing, of course, because this is an integrated circuit, this little bit here, I don't know if you can see that, and so is that one. It's a different style, and that's a different style. And the sad thing is, of course, that the smaller they get, the harder they are to work with. Like, I don't think I could possibly solder that thing on. There's a chance I might be able to solder this kind on. So these are all surface mounts, so they sit on the top. And these ones are through-hole ones, and they go through little holes in the circuit board. But these are the only ones you can use on breadboards. So these are called, this is a DIP IC, so that stands for dual inline package, I believe. That just basically means it has legs and it sticks through here, and there's this kind of size. So they all come in a standard, roughly standard size, but they come with different number of legs. So this one's got 8 legs, and this one's got, I think, about 16 legs, or 14. I think it's 16. So I'm going to make sure I'm actually pointing at it. I zoomed in a little bit. I thought that might be good for tonight, but then maybe that's a bad idea. So anyway, how do you use these things? So the interesting thing is, of course, is that they come in many varieties, not just different shapes, but they come in the same shape but do different things. So they all have a specific purpose. So a very modern day one, or a more advanced one, like this one here, this big chip here, is basically a little computer with lots of bits of extra bits and some memory and stuff, all in one little chip. And that's what it's basically. It's called a microcontroller, and it's the heart of these little Arduino board things, and it does all the work. So it does so much stuff. But it's nothing compared to what other ICs do, which do way more stuff. And in fact, this one here, I think, is also another little microcontroller that just talks to this thing here, and then talks to that thing there. And that's even smaller. So, but if you look on your modern day computer, they have big ones that do, like, are astronomically more advanced than this one here. And this thing here is astronomically more advanced than this thing here. But still, these things are fun because they let you make cool little hobby circuits and little crafty things, and they're still interesting. So this one here is a 555 timer. You cannot possibly read what's written on there, but there is actually stuff written on here. This is just a Chinese clone. So it doesn't have, it does say Texas Instruments on it. It has a Texas Instruments, I can't say that word very well, symbol on it, but I don't think it really is. It does work though. And this one here has a strange number. So they have these little numbers, and this one is a CD40, so it says CD, which is Texas Instruments, 4049, though I think it's also just a copy. But this chip has a specific function, and so does this one. Tonight we're going to try out using this one just for an example. And the important thing is they go a certain way around and they have all these little legs, and the easiest way to use them with these things here is just to stick them in the middle. And before we do that, they are marked in a certain subtle way. So usually they're marked by having a little, I don't know, you can't possibly see this. Maybe you can. I'm surprised when you look at it, when you look at things in the afterwards, that you can see a lot more than I thought you could see. But there's actually a little groove bit, a little, not a groove, but it's a little groove that goes like so. Hold on, I must get some paper. I was ill prepared. That was close. Alright, so they look a little bit like this on the top. So that's the case. And they have their little legs. They look like that. I'm only going to draw a selection of these little legs in no particular order. But they have at one end a marking. Sometimes the old ones I think have a little circle somewhere, but usually they have like a little indentation that looks like that on one end, and that sort of tells you which way around to put them. So this one has its little end over here, so I'm going to put that one in here. Now these things are kind of tricky. I've gone and misplaced my little tool to do this with. Which is good, because if you're watching this you may not have the tool, and so you don't want to see me doing it with the tool. But the legs, when you get them out of the box, and the box looks like this, so there are many varieties of boxes that they can come in. They are slightly too far apart, so they're very hard to put in the first time you do that. So you've got to kind of bend the legs a little bit, and so I guess you can just do it by pushing down like that. They don't have to be pushed very far, and then they should hopefully just go in and put them the wrong way around. I have a cute little thing that actually just puts them in exactly the right position, and then they work. So now they fit in there. They're pretty hard to get out. There's also a tool for getting them out, which I've misplaced as well. That tool I would recommend getting, because otherwise they can be hard to get out without bending the legs again. We'll try that in a second. But how do these things work, and how do you know? Well, you basically have to look it up on the internet. But if you look, if you're lucky, you can get some old books. I'm going to have to zoom back out. Which way does it go? It goes this way. Alright. Back to the old zooming games. Alright, so this book here is the Integrated Circuit Hobbyist Handbook. So this is quite an old book. But it's quite a useful book for people like me who just like playing around with these silly little things. And it has all these little charts and diagrams that tell you what each of the legs do. And this looks very complicated if you haven't done electronics before. But that's what this channel is for, because I'm going to go through lots of different ICs over the course of this channel and just talk about them and have a play around with them and see if we can come up with them any useful functions for them. But if we look in here, this book does not actually have that chip I just had a minute ago, which I've lost. Sometimes they're called chips, by the way. So if I call them chips, that's because that's what people call them sometimes. That's a 4049, but this book doesn't have the 4049 in it. It has a similar one, which is the 4069. So it doesn't actually give you any interesting... oh yes, we can look up that. So this chip here simply is for inverting inputs. So these are used for digital electronics. And digital electronics just means that we pretty much just work, or we pretend to work with a high voltage or a low voltage, and then we put those all together and we get other answers that are also in high and low voltages. And you'd be surprised at what you can get out of that. And in fact, what you can get out of that is modern day computers. So it's not so silly as you think, but this one here seems to do a rather pointless function. So this will tell you what the little legs mean. So these are little symbols that have particular meanings. So this little symbol here is a triangle with a circle. I might as well just draw it here. So this is the invert signal. So if this thing here was a high voltage, or like 5 volts, I'm just going to write it, I'm sorry if it's upside down, 5 volts, and then the output would be 0 volts. But if you did 0 volts, then the output would be 5 volts. Well, kind of, approximately, sort of. The point is, they'd be above a certain value, and when I say 5 volts, I really mean a high, and high means just above a certain value, and low means below a certain value, depending on what you're using. But for this thing here, that's how it's going to work. So you might think, what is the point of something that just turns one thing the other way around? Well, I'm not going to go into that tonight, but this is actually a surprisingly useful chip. You can do some cool things with it. So we're going to do a not a cool thing with it. We're just going to get it to work. And the first thing we need, and I had it just here, and it's disappeared the very second I want it. Oh, it's right here. It's right in front of me. So we're going to attach a little power board thing onto here, making sure we get it the right way around, which is on this side. So plus goes to the plus lines, and here. So it won't do anything by itself. But if we look at the picture, these things always have, these have to be powered by something. In this case here, it's marked them, so this is the ground and this is VDD. This basically in this case here means where we put the positive voltage, and that's where we're going to put the low voltage or the negative voltage to power it up. So I'm going to get some small little wires out. There's only one little problem with that. That's not the actual diagram for this chip. So I have this book here, which is the Cmos cookbook, and we're going to find it in here instead. So this one does have it. So you might think, why have you got two different chips and why are we doing different things? Well, they both do the same thing. So this is the 4049, the hex inverting buffer and TTL driver. Forget all that part for now. Hopefully you can see this. The important thing is that it's laid out differently, and there's actually 2 pins on this one that aren't used for anything. So the other one, the 4069, is in fact got 14 pins, and this one has 16 pins, and so but it does exactly the same thing essentially, and so there are 2 extra pins on this one. So I guess when they made this one, because this is an earlier number, everything was in a 16 pin package, and then they thought, hey, we can have 14 pins later on. I don't know, maybe that's how it works, maybe not. So anyway, we can look at this diagram, and we're going to have them both on the same page. And my little collection of wires. This is not the one that I wanted though, because there's all I'm running out of short wires in this one, so it's going to look a bit dodgy. Alright, so we're going to use the right kind of colors. Well, no, we're not. We're just going to use different colors. So this one here says that the power input goes over here. So I'm going to put the 5 volts onto that line. So remembering how these things work, so by connecting a wire from the positive rail onto this line here, I'm now giving this little pin here plus 5 volts, because it's coming out of here, it's at 5 volts. So I have got this basically the same way around. So the little curvy bit is on this side here, which you can't see because it's all black. Alright, so we've done that, and then we need one more wire. Where was the shorter wire? Here we go, we'll use a purple. And so most of these ones that are in this series, so they have like series, and this one's the 4000 series, a good chunk of them have things in the same place. The power supply is in the same place, which is good. But then they have these ones where the power supplies are completely different places, and it's kind of like, oh, well, that's a bit annoying. So that one goes there, and that one goes there. So now we've powered it up. So that's the negative, and that's been plugged into the negative and the positive. And now we need to have an output, and we're going to use an LED. I'm just going to get one of from my little collection of LEDs. What does that one say? It says white. Well, that's boring. I'm going to go with my favorite little green ones. In fact, I've never used these green ones before. These are not my favorite green ones. These are square-shaped green ones. These were for my planned... at some point we're going to be doing a one-dimensional Pong game. So that's probably going to be a Arduino project, which will be probably my next, or the second next Arduino project that I'm going to do here on this channel. The next one, the very next one, is actually going to be about chickens and sheep and or lettuces or something, or that farmers crossing the river puzzle, which sounds ridiculously boring, but I think it will be interesting. So anyway, this one says that, to read this, how much time have we got left? 13 minutes. That this one goes in here, that the signal in here is inverted, and so the invert comes out of this side. So these two pins here are linked together as a inversion. So these are called gates. So this is a NOT gate, or inverting gate. So the output will not be what the input is. So the input can either be high or low, and so the output will not be what the input is. So if the input was high, it will not be high, it will be low, and if the input was low, it will not be low, it will be high for the output. If that makes any sense. So we're gonna test out what the output is. I'm gonna put this that one doesn't fit properly. I'm gonna fit this ginormous one here, and it's gonna go over here. We need a button, I think, for this. This is the kind of stuff you want a button for, and I just happen to not have any buttons. Where did I put all the buttons? Alright, I do have a box. Where's my giant box of buttons gone? Well, this has turned out to be incredibly well organised. Oh dear, what's in this box here? No buttons. This is a box full of no buttons. I think there were buttons in here, but there are no buttons in this one either. I hate it when you have to actually move to get everything. Well, we'll just use the switch. I wasn't going to use the switch, but we are going to use the switch. Alright, so the switch is going to be connected with one of these little wires, so we'll use this. So I'm going to plug in the output of the switch, so the middle pin of that switch. So watch my switch video for these exact switches here, and that's going to go into the input. So that's going into pin 7 of this thing here, and then the output will come out and it will go here, and it's got just enough power to run an LED, but you can't, well, not enough power, power is the wrong word, but just enough ability to provide current to make an LED turn on. And so we're going to plug the little LED into here. So I'll just explain this when it's finished, and it's going to go to the negative thing. So right now, whatever it goes into here will be inverted or knotted, go through here. Knotted is the term that you use if you do computer sciencey stuff. And then you come out, go through the resistor and into the LED and out here. So if this is a low voltage and it's going down to the ground over here, so this wire is leading out to low. If this is a low voltage coming out of here, then there won't be any voltage difference between the two bits and the light won't come on. But if this is a higher voltage, then there will be a voltage difference and the light will come on. So let us try and see what happens. We need 2 more wires. And I'm going to, I feel like I should actually do this properly, but I'm not going to. So the problem is you can't actually tell. Yes, there is a way we can tell. So we need. I've got no more short wires. Oh dear. We may have to cut one up. Oh, there we go. That one's kind of short. It's funny because I had 2 boxes of these on this table, and now I've only got 1 box, which means one of them must have fallen on the back of the desk. Which is sad, I think. It's very sad. Alright, so actually we're going to change this. So this one's going to go over here. And we're going to get another LED out. This is going to take a bit more time. Hold on. Another green LED. Because I have to prove to you that they are in fact high or low voltages going out of the switch. So this is coming out of the switch, and it's going to do 2 things. It's going to, I have to stop using these giant thingy. There's a button right there, I can see it from here. So we can't go mixing. We can't mix it in with the lines with the so don't go crossing over and using these pins here if they're not doing anything. You're supposed to set the inputs to a particular value if you're not using them. But we won't do that tonight. And I've run out of room. I've run out of small ones. So we're gonna cheat and we're gonna use these ugly things. So it's gonna be a giant one there. And we need one more wire. So this kind of needs a circuit diagram, but it's not going to work. Not going to happen tonight. So time to explain. So the switch has been connected up. Please watch the video on switches. So the middle pin is going over to here, which I will explain in a second. And one side of the pin goes to the negative and one side goes to the positive. So if I switch to the left, it's going to be connected to the negative, the low voltage. So what's going to come through the middle pin will be a low voltage, and if I connect it to move it to the right, then I'm going to get the high voltage coming through. That doesn't really fit properly. I think that one's going to cause me problems. Hold on. Alright. Oh, that's being mangled up a bit. So if I turn it to the right, then this will be a high voltage, and it's going to come over to here, and one way it's going to split up. So we haven't talked about parallel circuits yet, but we will at some point. It's going to be split up into two directions. One direction is going to go into the IC, so there's going to be a high voltage or a low voltage going into the IC, and then it will split up and also go into this little bit here, which is just the resistor and an LED circuit going to ground. So it's going to go here. So if this switch is set to high to the right, then this little LED should come on because it's getting a high voltage, and if it's set to the left, it will be getting a low voltage, and so the LED won't come on. But because this thing is going through this circuit and being inverted, this one here should be the opposite state to this LED. So only one LED should be on, but when I flick the switch, the other ones should switch on and the first one should switch off. So let's cross our fingers and hope that this actually works, because it might not. Alright, so it's on, and that looks right. So that's not as exciting a little green light as I thought it was going to be. And so now we're going to flick the switch, and whoa, look at that, it actually works. Who would have thought? It's a little bit dimmer because it doesn't give out so much current. And it's not really the way you should be doing things. I don't know if this one really drives, but it says it's a TTL driver, so I would think that would mean it could drive a bit more current through here. So we'll talk about that when I fully myself understand the differences, and I'm kind of getting there. We'll talk about the differences to kind of how these chips work inside and what TTL might mean. But that's way down the line and doesn't really matter for most modern day things. So anyway, so now that's kind of how it works, and it switches like that. So that seems like a very boring application of this. But believe it or not, there's a lot more you can do with this IC. And there are so many other ones. So we are going to have a series of... Is it even possible to see this? We need to turn some of the lights off. Turn the lights off. Just so that you can see that they do. I guess because the wires are in the way. That yes, they are switching on and off. Dun 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 dun. Dun, 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 dun. Anyway, sorry, I was just being very amused by that. We're going to do a series of these things about all the different 4000 series ICs and seeing if we can work out. I think I mentioned that, but we're going to go through all of these, and I've got some pretty rare ones now, so that should be quite exciting. I think it will be exciting. I don't think anybody else will. I see the pits. This is it's a common thing for some people who are doing electronics channels to try and start this off, and then they get through like 4 and then they sort of give up and don't come back to it. But I'm going to stick with it, and we're going to get through lots and lots of different ICs, and we're going to do lots of other cool little ones as well, and just talk about how they can be useful. But that's just going to be one part of what this channel is about. But the next time we talk, I've gone and lost them all. Oh, what are these ones? Oh, these are kind of ICs, but these are I don't even know what kind of package they are, or even how to get them out of here. But anyway, why are they sitting on my desk? Alright, well, we're going to do... There's no point showing you them. But if you were the people who did the electronics day with me, I gave you 3 of these ICs. One of them is this IC here, the 4049. One of them was a 555, which is that one there. And the other one is this LM, there's no point, it looks exactly the same as that one, this LM324. And so we're going to have a couple of things about LM324s. They're not a particularly special IC in any way, in fact they're very old, but there's still some fun little things you can do. And if you're waiting for that, how do you make things go on and off when it turns dark or turns light, that's what we're going to use as the first way of doing it, and then we'll do another way later on. But we can also do lots of other cool little neat little tricks with it. Same with this IC here, which is why if you did that day with me I gave you these 3 chips, because you can do some kind of cool things with them. You don't really need this one. This one here you can actually do lots of stuff that you can that you're probably going to end up using this thing for. But I'm very excited about this. Like, I'm quite impressed by this IC being able to do a lot more than you think it can. So don't go judging something before you've done it. And later on we'll do ones like this. There's a whole packet of 4011s. These are very, very common ICs. And we can just quickly go back here. I'm pretty sure it's a NAND gate. It's a quad 2 input NAND gate, so it probably makes it one of the most popular ICs ever produced. So these kind of ones are actually made either in the late 70s or in the early 80s. This one, the 555, was I think designed sometime in 1972 or something. And is hugely famous in 1974 or about then, and is the most widely produced IC in the world. These cost 3 or 4 cents or 5 cents or something if you buy them off AliExpress. And these cost about, you can get these for a packet of, I bought a packet of these, 100 of these for just over $10 or $11 New Zealand. So these things are very cheap. Same with LM324s. They're ridiculously cheap. So yes, that's that for tonight, and we're just out of time, so that was a very long video. So thanks, and stay tuned for the next exciting installment.